Okay, welcome back to the class. And in the last video, we have seen how we can develop a crystallographic planes, and we have learned about the concept of the intercept. We learned the concept of the reciprocal, and from there we will clear the integers uh, or the fraction, and it will make to we will make to some values, and after that we will develop the Miller Indices. Okay, to just refresh these things, let's consider these two examples. Like this is consider a plane like this. So we can see that along x-axis it have intercepted just the unit, so it is 1. Here it intercepted again at y-axis at 1, and is at almost at half. So the intercept on the axis is 1, 1 and half. Okay, coming to the reciprocal of this one, taking we will get 1, 1 and 2. So since there are no integers here, we can directly use the same value. So the Miller indices will be like 1, 1, 2. So that is the plane. Okay, now let us consider this plane. Okay, it intercept x-axis at 1, at y-axis at the 3/4. Okay, so it's 3/4, and again the z-axis at 1/4. Okay, so it's a 1/4. So the reciprocal will give 1 and 4/3 and 4. Okay, so we will the fraction here, we have got a fraction that is 4/3. So multiply throughout with 3, we will this fraction will be removed. So it will be like 3, 4 and 12. So it will be the Miller indices will be like 3, 4, 12. We can write the 3, 4, 12 plane like this. Okay. So now coming to another example. Okay, this intercepted this plane intercept x-axis at 1, again y-axis at 1, and it intercept, as we discussed earlier, this one at intercept at infinity. So it will be like 1, 1 and infinity. So taking the reciprocal, we will give it will get like 1, 1, 1/1 and 1/infinity, which is 0. So clearing the integers, like we will get like 1, 1, 0. So this will be the Miller index of this plane. Okay, so these are the different planes, and yeah, for these planes actually we will get different what to say, different Miller indices also. You can try this one. So until now what we have discussed is just like someone is giving you a plane, okay, and you need to develop the Miller indices for that. Okay, this is what we learned just now. Okay, so if you go to this website, okay, if you go to this website, this is a very good website, and you will get a thing like this, and if you enter the values, you will see, you will get some plane. Okay, so that's what we are going to see next, how to draw the plane if the Miller indices are given. Okay, so I am considering few examples right here, and like for example, let us consider for the first example, like for the Miller indices, the given Miller indices is like 1, 0, 0. Okay, so this is the Miller indices given. Okay, so like a small actually this is very simple. So let us try something different. So here we can try something different, so that it is 2. Okay, so this is somewhat more complex. Let us see how we can draw a plane if such a Miller index is given. Okay, and before going into this one, let me write few things. I have an x value is there, y value is there, and an z value is there. So these are the 3 values, and if I am going to write the intercept, I will it will be like this. So it will intercept at 1. So the sorry, I'm going to write the Miller indices from here. The Miller indices like 1, 2 and 0. Or the intercept, I am going to write intercept, so it will be 1 by 1, that's 1. And here the, or the reciprocal, in the other terms I can write it as some reciprocal, okay, or the bracket intercept. So here it will be the reciprocal, will be the half, and here it will intercept at infinity. Now let us see how we can draw this particular plane in a unit cell. So I am going to draw a unit cell. Imagine this as a unit cell. Okay, such a unit cell is drawn, and for the time being I'm taking this as the origin, and taking the axis or the coordinate system. This is x, this is a y coordinate, and here it's an z coordinate. Okay, we got the values here, and what we see is that the intercept at x is equal to 1. So since this is a unit cubic cell, we can imagine the edge length as a unity. So here it intercept at x, so here it will intercept, and for the easy representation I will just change the color. Let it be this color. Okay, so at here at 1 it intercept. Okay, at intercept at 1, and you know that it intercept at half in the y direction. It intercept at half. So here it intercept, and regarding z it intercept at infinity. So we cannot draw this line here. So in that case, we will join these 2 points. So here also, since it's a plane, we are drawing it here. Okay, this is the plane. This is the plane which represent 1 to 0. Okay, first I will explain it once again. First we will see the given Miller indices is taken, and the intercept of the indices is written here, and corresponding the intercept are written here. Intercept or the reciprocal, in other words, will be written here. So the here 1 by 2 and the infinity, and the unit cell is drawn, and here we will write the value, the intercept here, and on extending we will get the plane. Okay, this is the first example. I think everyone understood the concept, and now we will move to the next thing. Okay, let us consider now the given Miller indices like 1 bar, 0, 0. Okay, so this is the indices which is given. We want to draw the plane for this type of Miller indices, and it is I already mentioned that this 1 bar represent a negative direction, or it will be like -1. So this is a new concept, and let us see how we can draw these negative direction planes. Okay, this is very important, and coming to it, as usual we will write the table that is we will write x, we will write y, we will write z, and here we will write the Miller indices, given Miller indices, that is 1 bar, 0, and so on. So the intercept or the reciprocal or the intercept will be written as it will be 1 by -1. So the reciprocal will be -1, and it will be 1 by 0 will be like the infinity, and 1 by 0 again will be infinity. So this is drawn, and now let us see how we can represent this one in a unit cell. And for that we need to draw the unit cell. Imagine that this is a unit cell with 3 axes here. This is x, this is y. I'm taking this as z. Okay, there are three axes here, and what concept is that this part we will take as the origin. Okay, now earlier all drawn planes, the origin was taken at this location. Now next thing is that we will see how we will draw this negative direction or negative plane. Okay, for that I will change the color. Okay, so this is a negative direction, and while taking the negative direction, okay, different textbooks explains in a different concept, so just try to follow one concept. Here see the negative axis. Here we have negative direction in x-axis only, no negative directions for y and z. So we need to change the origin from here to some other location so that we can draw the negative plane. We don't need to as shown earlier, we don't need to draw a different cube. Here we can change the origin. So it's a simple concept, try to understand this one. Here we have a negative value, this is a -1, that is in x direction. So if we change the origin from here to here, okay, from here to this location, okay, this is the new origin. If I am taking this as the new origin, so this will be the z, this will be again the y, and this will be the x. Okay, just shifting the origin only. If we change the origin, let us see what will happen. If we change the origin, and we are going to draw. Now let us see. This is -1. Okay, this is -1, and from this origin, if we change the -1, means this is the positive direction, positive x, positive y, and positive z. So negative direction means it will be at this point. This will be the point. And next thing is like it will not intersect the y-axis. So this is the y-axis, our new y-axis. So this is parallel to this y-axis, and here it does not intersect with any z-axis. So it is parallel to z-axis. In such a case, we can see that that plane which lies which is parallel to z, parallel to y, and negative to negative to x will be this plane. So this is that our new plane. This plane will be like 1 bar 0 0, 1 bar 0 0. So in this way we will represent the Miller indices for negative plane, and we will see the next example. Okay. So let us consider another example. Here we will consider the example like let it be 0 0 and 1 bar. Let us see how it looks like. So we as usual we will write x, y and z, and Miller indices will be like 0 0 1 bar, and if we take the reciprocal or the intercept, it will be like infinity, infinity and -1. So how to draw such a thing? So we will draw a unit cell, cubic unit cell. Okay. As usual, our original origin will be like x, y and z. Okay, so this is our origin. Okay, now we are considering like in x-axis there is no negative direction, y-axis no negative direction, but z-axis there is one negative direction. So let us see this origin. So if I change the origin, from here to here, okay, changing the origin, this will be my new origin. So this will be my new z, this will be my new y, and this will be my new x. So if I change the origin, let us see how it looks like. Now something parallel to x, okay, that will not intercept with x axis, no intercept with y. So that means it intersect y at infinity, okay, and it should intersect at z at -1. So this is the positive z axis or direction, and negative means which should come down. So this one will be the -1. So here it will be like this. So imagine a plane like this. This will be the plane. So if we take this plane, okay, if we consider this plane, then we can see that it satisfies all these conditions. Since this plane does not intersect x or intersect at x-axis at infinity, this one will intersect new x-axis at infinity, this one will intersect new y-axis at infinity, and this one will intersect z-axis at -1. So this satisfies the condition of 0 0 1 bar. Okay, this satisfies the condition. Okay, okay, now let us see another case. Here next case will be like 0 1 bar 0. Okay, this is the new case. Let us see how it will look like. As usual, I am going to write x, y and z. I am directly going to write the reciprocal only, not the Miller indices again. So the reciprocal will be infinity, and it will be -1, and again it will be infinity. Okay, now let us see how this one will look like. And I just personally tell everyone to pause this video and try to do yourself, because this is very simple. Okay, so this is just a unit cell. X, Y, and Z. Okay, and this is our origin, and we need to find the new origin because there is a negative direction came, so we need to find a new origin because we cannot proceed with this one. And in such a case, as told earlier, so simple thing, simple concept here. uh, it it has no direction change in X, no direction change in Z, so only direction change is there for Y. So here, if Y, we are moving it to this will be our new origin. So if we change it, this is our Z, this is our new Y, this is our new X, and we are changing it, and we are going to draw the new plane. Okay, which is parallel to X and Z, and with -1 dimension to the Y. Okay, if this is the point, and negative Y means here, negative Y comes here, and this will be the plane. This satisfies all the conditions because it's parallel to X, our new X, parallel to new Z, and intercept Y at -1. So this will be our 1 bar 0. So these are the three simple conditions, and I think everyone understood these things. And now let us see a new case, or the another somewhat a little complex case. Okay, so this is like 1 bar 1 and 0. Let us see how we can draw these things here, and it is very simple. I think we need to write X, Y, and Z, and finding the reciprocal. Okay, the reciprocal of 1 bar will be -1, and reciprocal of 1 will be 1, and reciprocal of 0 will be like infinity. Okay, and we need to draw these units. Here one, here another direction. So this is X, this is Y, and this is Z. Okay, now let us see how this happened. As usual, we can see the first thing what we need to see is whether the change is there. Okay, so the direction change is there only for X. For Y and for Z, there is no direction change. So we need to locate our new origin. Okay, we need to locate our new origin. So here our new origin will be like here. I'm taking it here. Why? Because from here to here, if we change, we can take the negative direction of the X. Okay, so this will be our new X, this will be our new Z, and this will be our new Y axis. Okay, now Okay, this is our new direction, and what we need to find is that now let us see the values. So intercepted new plane intersected x is equal to -1. So from here to here, so this is -1. It intersected -1, and intercept at new our plane intercept the origin by plus y. That means this is the positive direction, so here it intercept, and intercept z axis, this z axis at infinity. So we do so here we it's impossible to represent. So these 2 points, actually we need to join these 2 points, extending. Okay, this is how this plane will look like. So this plane we can represent it with 1 bar, 1 and 0. Okay, so I think everyone understood the concept. Okay, now let us consider another example. Now this is it will be like one we last example we have tried is 1 bar 1 0. Now for the time being we can consider like two negative direction, 1 bar 1 bar and 1. Okay, let it be like this. So as usual we can write the values x, y and z, and reciprocals are like -1 -1, and here it will be like 1. Okay, so we need to draw a unit cell. So this is x, y and our result. Okay, so since two negative directions are there, we need to change the origin. Okay, now we need to find the new origin. Here negative directions are the negative direction is there for x and for the y, so we need to find new origin. Okay, let us see this one. So anyway, our old origin is like here. So if I change the origin to here, this point, okay, let it be this point, so it satisfies the first conditions. Okay, we can take the negative x from here to here, and let's move to the next point, that is the y. Here we have a negative y-axis also, or -1 is coming for the y-axis. So we know that this is the y, and if I change the origin from here to here, it satisfies the second condition. For the third condition there is no because it's in positive side, so no change is required. So here two origins, not to satisfy two conditions, 2 points we have taken. But we know for drawing one plane there should be only one origin. So what we will take is that we know to satisfy this condition and not to satisfy this condition, we will take a common point of this one, that is this. This will be our new origin. So for the new origin, this will be our y, this will be our z, and this will be our new x. Okay, now let us draw the plane. Now let us take the plane, how it look like. So this is our origin. If I draw a -1 from here to here, this is the -1, and for y, sorry, this is the y-axis, this is the minus y. So this condition is drawn, and we need to draw the second condition, that is this one. That means this is our x-axis, and if I draw from here to here, -1 for the x also. But for the z, actually the no change is there. So here z, we need to draw it here. Okay, so this is the z is +1, so we can draw it. So in connecting all the 3 points, we can draw a plane. So this will be our new plane, that is 1 bar 1 bar 1. Okay, now let us consider one more last example, okay, of this category. Last example, like 1 bar 1 bar 1. Just see this one, how one can draw a Miller indices of such kind of plane. And here as usual we will write x, y and z, and the reciprocal of this one, like it will be like -1 -1 and -1, and we need to draw a unit cell. So this is our unit cell. Going to draw the coordinates. Take x, this be y, and this be z. This is my origin. Okay, since 3 points. Okay, at 3 points we have negative direction. In all the 3 points we have the negative direction. Okay, so let us see how we can draw this one. So at x, this is the origin, and if the x was at this point, the origin was at this point, the first condition was satisfied. And if the origin was at this point, the second condition would have been satisfied. Okay, and if the origin was in this point, the third condition would have been satisfied. Actually 3 conditions are there. We need to satisfy all the three conditions, and in such cases we can see that the common point which comes at this point and this point and this point, common to these 3 points, you can understand that this will be the common point. So this, we are changing our origin to this part. Okay, this is my new x, this is my new y, and this is my new z or c. Okay, and what we are going to see, we need to draw the plots, okay, for the plane, and let us see how it look like. Okay, and here we have x. What we need to do is that first we need to find the negative x. That means we need to satisfy this condition. So negative, this is the positive direction of the x, so negative direction, negative x will come here at this point. Next we need to satisfy this condition, that is negative y, and here the negative y will come at this point. And the third one is z or negative z, and we can see that z positive z comes here in this direction, and the negative z will come at this point. And on connecting these 3 points, okay, 1, 2 and 3, connecting all the 3 points, we can see that this is the plane which we are looking for. So it will look like 1 bar, 1 bar, 1 bar. Okay, this is how these planes are, or the crystallographic planes are plotted with the help of Miller indices. Okay, in short, the Miller indices are the 3 parentheses which is used to represent a position of an atom using some directions or some like what to say, a plane. Okay, this plane, if such a plane is mentioned, or if such a plane is given, we can say that an atom located here lies in this plane. Okay, or this plane actually describes the path where the particular atom lies. Okay, so such studies, these Miller indices are important, and you can try a few more examples. And for the time being, I am winding up, and thank you for the attention.